Good morning. We are about to head out for a day trip to Garwood Valley. Here's a little map. So I'm kind of looking from the direction of McMurdo. So we go across the ice. This is Taylor Valley. This is where I've been before. It's up into here, Lake Bonnie. There's Blood Falls right there. But today we're gonna go spend the time. One of these canyons over here is Garwood Valley. We're going to be going into there for a day trip. Going to put in some soil sensors that'll be there all year round, and then do some collecting while we're there. So pretty excited for another day trip. We'll get out there, see some pretty stuff. Oh.
All right. Okay, so this is the Garwood Valley. All that you see right here. There's the Garwood Glacier that we flew over coming in. That's the one that has the big thermokarst that we saw. He said the Star Wars looking thing, that big giant hole. So what happened is, as this river, this is a flow through river or lake. So it goes up and down. Eventually you get enough water that comes up and it can eventually spill out over the top. Most of the time it's at peripherally flow through lake. And there's that big Garwood Glacier. As that melts, that water runs along the side of the glacier and it creates thermokarsts. And so what happened is that river had eroded out a huge chunk underneath that glacier.
So caves.
And that, yeah, this huge cave. And then that whole thing just collapsed down, and you see the huge circle on top. That was all the ice that collapsed down under it. But before, when it was open, when it was up, you would see like a big cave opening, and you could go in there. Well, you don't go in there, dude, but you could be outside the entrance of that, and the stream guys that were measuring stream flow were telling me it sounded like a bowling alley in there, like just like bowling pins and bowling balls rattling around down in there. And it just kept getting bigger and bigger and bigger and bigger until it's the size of a basketball gym, and then that whole thing just dropped down, collapsed.
Wow.
Pretty trippy.
Man.
Over on the other side of the lake there's been some really cool soil experiments that have been done, looking at similar stuff to what we do: fertilization, CO2 exchange, and biogeochemical cycling. There was a big kiwi camp there for a few seasons, couple seasons. And that's the one where Phil used to have to climb up to the top of the hill every morning to do their check-ins.
Yeah, get calm.
Yeah. And the lake itself you'll see that it's pretty shallow out here. You'll get big moat out there, and the permanent ice is back in over there. And then the streams that come into it are off of this other glacier here. So that's where we're at. You'll find that the permafrost here is pretty shallow. So when you get up to the seaside up there, you might not be able to get down enough to get the sample that you want. You'll notice that some years we've been here, it's been entirely covered with snow, and so some of those plots don't even get sampled some years. And so this year it actually looks pretty good, but again, you might have trouble getting through the permafrost because this is a wetter valley than Taylor Valley. It gets a little bit more water, more snow here, and so more of that makes its way into the soil. And so because of that, your ice table is higher. It doesn't melt out quite as deep. So your permafrost, you're going to hit permafrost much shallower here, particularly since it's freezing but cold here. And those dudes, like when we came in one day and we hung out with those guys, you know, we were doing some work, we were doing transect stuff along the lake. We hung out with those guys, and we roll in and just say, "So how's it been?" And they just like, "Cold." Because it was overcast. You don't get sun, it gets cold. When you don't have sun, it just gets cold here, man. And so this is famous for being like this cloudy, cold valley.
That's how I come up with the Garwood.
Garwood. Working in Garwood. I should have brought my pirate dude out of it. Garwood. But this is of the 3 elevational transects, this is the one that has the highest abundance. And it has comparable biodiversity, but the abundances of those animals in the soil is really high here. And it's probably because of the amount of leaching. It's got higher organic carbon and a little bit more water. So we think that explains some of it. I got some nice pipe thread on there so that when the rocks and stuff get in there, it still works good. So if you look down in here, these are the data loggers. And one of them's for, this one's for 0 to 5 centimeters. And this one's for 10 to 20 centimeters. And then if you look straight in, you can see the rebar. So the rebar is pounded in, and that's reef. That rebar is like way into reef, into the ice-cemented concrete. And so no matter how windy this gets, it's not going to go anywhere because that rebar's in there. And then this small PVC pipe, that protects the leads. So they run all the way down to the bottom. And then those leads come back up, and they run out at the different lengths, at the different heights. So there's one at 20 centimeters, one at 10, you know, one at 5, and then there's one right on the surface. It's right up in here. And then, so what happens is next year I can come in and I can plug my little dongle to this dude off. And those lights there connect, they talk to my laptop. They send data from here onto my laptop just by, you know, flicking lights. It's like fiber optic, right? And so then I can plug that in, download all the data, swap out the battery, and then just put this back in here, and it's good to go for another year. So
plenty protected.
Yeah, so yeah, it should be like totally protected, right? Oh, I actually want those going. Yeah, that's the right way. So next year I should be able to come in and just swap out the batteries, download the data, and it should be golden.
Super cool. $200 instead of thousands.
Yeah. But I mean, that's like a $2,000 installation.
$1 million hole.
Yeah, it's $1 million hole,
Yeah,
and a $200 logger.